I am the Internet Skeptic, and we're going through making a series of videos on global warming. This one we have titled, Pay No Attention to the Man Behind the Curtain. We get that title from the movie The Wizard of Oz, and as you remember, there was this awful wizard that controlled society, put a great deal of fear in people. Okay? It took Dorothy to take a look behind that curtain, and once she did that, she realized there was nothing really fearful about this giant wizard. It was a big fraud. It was a man supporting all this. Well, in this situation, I would say global warming is a fraud being perpetuated on society. And you can see in this scenario, we're going to say the man behind the curtain is Lonnie Thompson. We're going to go and we're going to take a look at the research that he does. We're going to make a look at the claims that he makes, and we're going to look at the data that he has to support it. And we're going to ask you, the viewer, that once you understand the data, once you've looked at the charts and understand the theory, does the conclusion that Lonnie Thompson reached, does it or is it supported by the data that he provides? This is my favorite quote. It comes from Dr. Fred Singer, president of the Science and Environmental Policy Project. He had Al Gore come and speak to his group, and Al Gore comes up to him afterwards and says, well, Dr. Singer, what do you think of my presentation? Dr. Singer said, well, your presentation, it's very persuasive to those who don't know the science. And I think that's going to mean a lot to you by the time we finish up this presentation. All right, well, let's take a look and let's see what exactly are some of Dr. Thompson's claims. This is a presentation that we recently attended here at Ohio State University. It was given by the Mechanical Engineering Department. It was given by Dr. Lonnie Thompson. And in it, he reviews, and there's an assumption to this video. I'm assuming that the material that he provides and the theories that he provides are probably the best ones that he's got. I'm assuming that what he's giving or portraying to the public is the global warming theory is the global warming theory. And what we're going to do is we're going to take each one of his claims and we're going to analyze it. We're going to take a look at the data behind it and see whether or not they hold water. I also have some data in this presentation. It comes from An Inconvenient Truth, a skeptical tour. This is done by Mario Lewis, a senior fellow at the Competitive Enterprise Institute. Now these are the claims that Dr. Thomas makes. In this video, and we're going to review it, and in his presentation, he makes a few claims about global warming. He says, why the contrarians are wrong. Balance of the evidence. Okay. Models predict and data show that A, stratosphere cools as surface warms. Variations in the sun's output would instead cause similar trends in the two atmospheric layers instead of opposite ones. We're going to take a look at that claim. 2, temperatures have warmed more at night than during the day. This is unlikely to be caused by some variability in the sun, for example, and appears linked to the greenhouse gas that holds the heat radiating from the Earth's surface even after sunset. We're going to take a look at that claim. Temperatures have risen more in winter than in summer. Opposite that would be expected if the sun was driving temperature to increase. This is almost an embarrassing error when we take a look at this one. High latitudes have warmed more than low latitudes. Since more radiation is received at low latitudes, one would expect opposite if the sun was driving the change. There has been a parallel warming trend over land and ocean. The increase in the amount of heat-trapping asphalt cannot be the only culprit. And last but not least, several dozen top models have become progressively better at replicating climate patterns. And present, the only way to replicate the remarkable warming and extraordinary Arctic warming of recent decades is to add greenhouse gases. Those are the claims. Now, once again, these are not claims made by me. This, from what I understand, is the cornerstone of modern global warming theory. Each one of these is presented in a presentation here at Ohio State to some of the greatest minds in the world. This is what they claim. And we're going to take a look at this, and we're going to see, do these hold water? Okay. Are there problems? And we're just going to, once again, it's going to be up to you to decide. All this data will be provided at the internetskeptic.com. You can go download this presentation. Also, if you're there, please click on the Donate Now button. You can help me make some more of these videos. Okay. But let's go take a look at some of these claims. Okay. The first one. The model predicts and data shows that stratosphere cools as surface warms. Variations in the sun's output would instead cause similar trends in the two atmospheric layers instead of opposite ones. That's the claim. What we have here is right here you have a chart with latitude and altitude. And this green area down here at the bottom is water vapor. Water vapor is something you will rarely hear Dr. Thomas ever mention. And you're about to find out why. When I saw him in the presentation, he only mentioned it after he was asked about it. On the open line show with Fred Anderley, you will notice that he never mentions it. Okay? Dr. Thompson does a very good job telling you what he wants you to know, and he conveniently forgets water vapor in most of his presentations and in that open line interview. Okay, well, this is water vapor. And then over here, this is the water vapor content right here. This is water vapor, and as you can see, almost all the water vapor stays below about 12 kilometers. That's essentially the top of the troposphere. Then you go into the stratosphere. Okay? So over here, you have the majority of water vapor staying below the stratosphere. And then over here, you have temperature, you have latitude, over there you have latitude, and here you have altitude. Okay? As you can see, as you go higher, the blue is cooling. So as you can see, most of the temperature is contained here in this green area. Look familiar? Temperature, water vapor. They're almost identical. That's where most of your global warming comes from. Water vapor is responsible for 95% of all global warming. Now, take a look at the atmosphere as you go up with CO2. As you go up with CO2, it is constant. Now, if CO2 was responsible, and CO2 is constant throughout the atmosphere, wouldn't you have even warming throughout? But you don't. You have the warming concentrated to where the water vapor is. Here I simply take them and put them one on top of the other one. The top one is temperature. The bottom one is the level of water vapor in the atmosphere. Okay. Here I put them right next to each other. Once again, this is water vapor in the atmosphere. This is temperature. Do they look similar? Yes. My question to you is, why does Dr. Thompson never bother to mention this? Once again, if it was CO2, CO2 remains pretty constant as you go up. But temperature doesn't. Dr. Thompson himself will tell you that we have a lower troposphere, or a warmer troposphere, and a cooling stratosphere. This is in the north and the southern hemisphere. These are two charts showing CO2. They're relatively even, both in the northern hemisphere and the southern hemisphere. So what the message is CO2 is relatively evenly dispersed throughout the globe. Now this is what they're talking about. Now you're asking yourself, what the heck are they talking about? Cooling stratosphere, warming troposphere? Well, here you've got it. This is a report done by S.A. Clough and M.J. Icano, Atmospheric Environmental Research. That's a pretty impressive sounding name and pretty impressive sounding organization. Now let's find out how impressive their charts are. All right, here we on the top part here, what you see is, once again, that dotted line is the top of the troposphere, the bottom of the stratosphere. That area of two yellowish and green bands up in the top, that represents the cooling. So Dr. Thompson is right. Stratosphere is cooling. Okay? But what is he blaming on? He's blaming it on greenhouse gases, namely CO2, and not the sun. Well, first of all, that's a normal phenomenon. It has always occurred and always will occur. Okay? But look real closely up there. You'll see that big band, the big area of cooling, happens to be labeled CO2. I don't know if you can see that, but there's a label up there that says CO2, and it lines up exactly right here. Okay? Well, if you look at the chart a little closer, you'll see they have a wavelength labeling down here at the very bottom. If you drop the center of that large cooling area straight down, it lines up almost exactly with 6.5 microns. CO2 doesn't absorb at 6.5 microns. CO2 absorbs at 2.7, 4.3, and 15 microns. Nowhere near where that cooling band is. But, and here we have it, the IR absorption bands for carbon dioxide and water vapor. And lo and behold, what do you notice? That cooling band of 6.6 or 6.5 happens to line up right here, which happens to be what? The peak level of absorption for water vapor. has nothing to do whatsoever with CO2, and yet they label it CO2. Okay? Now you're thinking, well, maybe that's just a mistake. Maybe these experts in this environmental research company, these professionals, made a mistake, is what you're saying. Well, that's nice. There's another band off to the right there, right? And we look up there and it says it's right at 10 microns. And what is it labeled? O3, ozone. And you know, want to know what? If you take that and you look up on the IR spectrum, you'll find out that infrared lines up exactly with 10 microns. So somehow they're able to accurately label ozone. They mislabel CO2 to work to their favor, and they totally forget the fact that that band is water vapor. And these are the professionals in the environmental group. Here is the actual wavelength and absorption charts, and as you can see, ozone being the third one down, you have this nice little peak. Right here's 10. If you go straight up, right at ozone. So they labeled that one correctly. And when you look at CO2, you see a band here at about 4.3, and you have a band here at 2.7. Over here, 6.5. CO2 is flatline. It has nothing whatsoever to do with CO2, and 100% to do with water vapor. So Lonnie Thompson is correct in saying that the stratosphere is cooling through a normal phenomenon caused by water vapor. You increase water vapor, you stop IR radiation from making to the stratosphere, so it does cool. But once again, it has nothing whatsoever, according to their own charts, to do with CO2. Okay? Here's another suspicious thing. CO2 is even throughout the globe. Well, Dr. Thomas himself points out that there's areas of warming. You know? And by the way, we don't have global warming. We have northern hemisphere warming and southern hemisphere cooling. But even he points out that you have pockets of warming. If CO2 is evenly divided throughout the atmosphere, why would you have that? You would expect it to be even. They also, these are the charts of their CO2. Okay, and these are historical charts from the Vostok ice core of CO2 going back 400,000 years. And these are predicted levels. They show CO2 shooting through the roof. And they're claiming that man, because of man, all this new atmospheric methane and CO2 is being produced. I don't have any evidence for this one, but I remember reading stories about how the buffalo used to blacken the plains. There were plenty of methane-producing animals back then compared to today. We may have more men, but these things used to be so numerous they would blacken and take days for these herds to go by. So I'm not so sure about these claims that today's atmosphere or today's environment is producing a lot more methane and CO2 than what used to have, just considering the giant biomass that used to roam the plains. Okay, here's the other one. This one's a little complicated, but it's really interesting. Models predict and data show that temperatures have warmed more at night than during the day. This is unlikely to be caused by some variability in the sun, for example, and appears linked to the greenhouse gas that hold the radiation from the Earth's surface after the sun sets. That sounds, and this is what's so dangerous about this global warming theory. It sounds so plausible until you look behind the curtain. Now think about it. He's ruling out the sun. Well, think about what the sun's doing. During the daytime, you're being hit with IR radiation, but in the daytime, you're being hit by the full spectrum. This is basically a measurement of energy and wavelength. As you can see, blue light is extremely energy rich. Okay? The way you can view a wavelength is think of a slinky. Okay? A blue wave is like if you take a slinky and compress it. You get a lot of slinky per meter. Infrared is if you take that slinky and you stretch it out. Okay? You get very little slinky per meter with a infrared, but you get a lot with blue light. So what that means is that to get an equal amount of energy from blue light, you need a lot less blue light to match the energy output of infrared. Right? You can take 10 slinkies, line them up to meet 1 meter of infrared. Okay? So a small change in the sun, which delivers a lot more blue light, would lead to a lot more release of infrared at night. Okay? Because each one of those packets of blue light has 10 times or so the energy of infrared that gets released at night. So there's not a linear relationship between sun's output and infrared radiation at night. You just need a small change in the sun output to greatly increase the infrared release at night. Okay? And so what's going on is the sun changes a little bit, provides a lot more blue, and at night you can release a lot more of this red because one little piece of blue means a lot of these reds. It's a little complicated, but that's the physics of light. Think about it this way. Think about if you took a thermos of or a cup of coffee and you heat it up to 100 degrees, put it in the thermos, and closed it up. And then measured the temperature an hour later. It would go from 100 down. What happens if I heat it up to 130 or 140 and put it in there? The temperature would be rising, and you would retain the heat longer. That's all that's going on. You can think of the nighttime as being a thermos. The key is, during the day, you're putting in hotter coffee, and so you can expect when you measure the temperature at night, the heat would be going up. That's what's going on. Normal physics, once again, it has nothing to do with CO2. Okay? Also, as far as their temperature measurements, this comes from NASA. These are rocket scientists who make a living out of measuring this data. They have satellites and balloon measurements of temperature, and you can see recently much scientific debate has focused on the global temperature of the Earth's lower atmosphere by orbiting satellites. Now this is the key. And while this data are exceedingly precise, verified by multiple satellite observations and balloon temperature measurements taken in situ, they reveal no discernible warming trend in the Earth's lower atmosphere over the last 18 plus years. So Lonnie's claim, for one, is in direct contradiction with some rocket scientists. Their data shows there's no warming. However, what I thought was real interesting is in his presentation, Dr. Thomas will use these charts. And they look pretty impressive. They show temperatures increasing across the board. The first thing that caught my eye was, anytime you do this kind of stuff and you're going to use charts for comparisons, you want to use apples to apples comparisons. Right? Well, take a look here. Measuring warmth. Okay? 10 warmest years in black. Highlighting this. Okay? Look carefully though. Okay? Change in annual temperature from 1901 to 2000 baseline. He has a 100-year average that he's comparing it to. Of course you're going to get these exaggerated extremes at the end if you warm just a little bit. This is just simply a statistical game to exaggerate the warming. Okay? Go over here. Remember over here we have 1901 to 2000 for the baseline. Look here. Suddenly you've got 1961 to 1990 baseline. Now why would you be doing that? One, I don't know. But two, this is the way I would do this if I wanted to lie with statistics. I would have apples to oranges and claim that it's apples to apples. But once again, you can see change in nighttime low temperatures. So he can come up and he can create data that shows an increase in nighttime temperatures. But once again, the nighttime temperatures is consistent with a small output of blue light from the sun. Okay? Oddly, he changes the baseline. Then over here, you get a different baseline. You've got 1984 to 1990. He's shortening the baseline in each one of his comparisons. Once again, change in stratosphere. So he can show you, sure, he shows you nights getting warmer if you use that baseline. Then he shows you the stratosphere is cooling using this baseline. But you don't know if you use the same baseline what kind of data you would get. The most humorous thing, though, this is one of the world's greatest scientists, right? You would think he would be able to get some great research. Look here. The New York Times. Anybody who uses the New York Times as a source, to me, is questionable to begin with, all right? Okay? Actually, this comes from the National Clients Data Center from University of New York, Huntsville. But to be honest with you, do you think anyone at the New York Times would even understand the mathematics behind this and understand the monkey business going on with these baselines? I can give the New York Times a pass, but Dr. Thompson, come on. Okay? This is the one that is almost embarrassing. I even hate to review this one. Okay? Models predict and data show that temperatures have risen more in winter than in summer. Opposite that would be expected if the sun was driving temperature to increase. Dr. Thompson obviously failed elementary school science. The northern hemisphere happens to be closest to the sun during the winter time. If the sun was heating up and you were closer to it, don't you think you'd get a little bit of warming? Perihelion, which is when we're the nearest to the sun, occurs on January 3rd for the northern hemisphere. Dr. Thompson, once again, it sounds plausible. Wintertime, you're warming. If it was due to the sun, you're the closest to the sun during wintertime for the northern hemisphere. So yeah, it's logical. You doubt me? You can do your own little experiment. Go home, turn on the burner, and take your hand closer to the burner. I'm willing to bet you'll notice it gets discernibly warmer when you get closer. And that's what's going on. Once again, Dr. Thompson tries to rule out the sun, but if you really understood what was going on, he's making a case for the sun. The key is he's too blinded by ideology to even recognize the basic science behind his claims. Okay, here's another one. Models predict and the data show that high latitudes, meaning the northern hemisphere, warm more than low latitudes. Okay? Since more radiation is received in low latitude, one would expect that if the sun was the driving change. So what he's saying is, because more sunlight is received in the lower latitudes, if it was due to the sun, you'd expect warming. Okay? But think about it. CO2, their own charts show, is evenly divided in the northern and southern hemisphere. So if you have even distribution of CO2 and more sunlight coming in the southern hemisphere, but it's warming in the northern hemisphere, doesn't that mean that CO2 is actually causing cooling, not warming? Because the southern hemisphere would have more light to trap, and if CO2 is doing the trapping, you'd expect warming. So once again, his logic is totally backwards. Okay? CO2 is evenly distributed. If that's the case, and that's their theory, temperature would be evenly divided around the globe, but it's not. Okay? And his own case is making an argument that if CO2 traps sunlight, wouldn't the area where there's more sunlight to be trapped be warming? The southern hemisphere would be, yet it's cooling. So once again, Dr. Thompson, I don't understand the logic of where you're going with this. Here's basically a chart that shows you the southern hemisphere is cooling. Okay? Northern hemisphere is warming. They even admit that, and yet they tell you it's global warming. How can you have global warming if you have southern hemisphere cooling and northern hemisphere warming? It's not global warming, it's hemisphere warming at the best. Okay, once again, and what do you notice? If you take a look and you go back to water vapor, all this data is available, they just seem to fail, they just seem to either not want to recognize it or not admit it. Where do you think the increase in participation has been? You got it, the northern hemisphere. Lo and behold, you got an increase in precipitation, and you got an increase in temperature. That's not rocket science. Okay? The key is you have to admit that water vapor is what's driving global warming, and the moment you do that, Lonnie Thompson no longer gets these free trips around the world to go give his lectures, tours, and do his little ice core drilling in these beautiful resort places down in South America, Africa, things like that. Okay? Precipitation changes per decade. Okay? Increase in 20%. You see a lot of yellow and brown up in the top. Okay? The dark brown is dryness. What do you see? A lot of dryness down in the southern hemisphere. Lo and behold, by the way, this dry area seems to be in areas where what? Dr. Thompson does his glacier research. And we're going to get to that. But remember that chart. Remember where the dry areas are. And we're going to go back to it. Also, at the very top, you see temperature changes. A lot of red up in the top and a lot of precipitation. So you got a lot of precipitation and you got a lot of increase in temperature. Once again, it's water vapor. I don't see CO2 anywhere. But once again, I do want to drive home this because we're going to get back to this. See this little spot here of dryness? And this little spot over here of dryness? We're going to get back to that. Okay? Well, once again, you have all these surface temperature anomalies. CO2 is evenly distributed, and yet you get these temperature anomalies throughout the globe. You got warming and then cooling. And once again, I'm pointing out right here, this little blue area, that's cooling. So remember, that little area is cooling, and we also saw that it was drier. That also happens to be where Kilimanjaro is. Models predict and data shows. Here's the next one. There has been parallel warming trend over land and ocean, and an increase in the amount of heat trapping asphalt cannot be the culprit. What he's getting there is saying many people say that it's the urban effect that's causing this global warming, meaning that a lot of these thermometers are placed on blacktop, tar roofs, things like that, and it's called the urban effect. Cities trap a lot of heat. That's also where all the temperature measurement gauges are, so they give an artificial, or they bias the temperature measurement upwards. Okay? But once again, he's saying there's a parallel warming over land and ocean. Okay? If it's parallel, don't you think that would possibly be due to the sun? Or maybe that water vapor that we saw, it's also parallel. CO2 is not the only one that's parallel. However, we do know CO2 is parallel. And once again, think about it. The sun, if it is increasing at a certain rate, the world would be getting an increase at a certain rate, so you would expect a parallel increase across the board. Right? That's what I would think. Here's another one. Models predict, and data shows, that several top models have become progressively better at replicating climate patterns, and present, the only way to replicate the remarkable warming and extraordinary Arctic warming, okay, for one, I don't think there's Arctic warming, we're going to get to that, of the recent decades, and is to add global warming gases. First of all, several dozen top models. Well, what do the other several dozen top models show? Okay? If you look over here, you'll see that the models, just by themselves, with no man-made cause, do an awful job of predicting. They don't catch that last spike in temperature. Over here, you see that by adding man, you can adjust for that very end spike. Okay? Here you see that gap between the gray and the red, meaning the model doesn't predict the recent temperature very well. Over here, what they claim is you throw in man, and it matches perfectly. As if for some reason man didn't exist before 1950, or what is that, about 1970. Okay? So before 1970, man didn't really exist, and the model does a great job predicting it. After 1970, we say man has all the costs. I guess man just suddenly started influencing the environment in the last 30 years. Okay? And then when you add all four things together, you can see they come with a nice correlation. The key is, data that you put into these models is the most critical factor. It doesn't matter how many supercomputers you've got. It doesn't matter how many models you've got. If you put garbage in, you can get garbage out. I could do the same thing if I added the height of a tree starting in 1970. Okay? If I wanted to impact this model or make this model needed, I would just simply throw in the variable of the height of a tree starting in 1970, and I could probably tweak that model to give me the results that they're showing here. That's not very impressive at all if you understand multivariable modeling. Okay. Lo and behold, let's take a look at their temperature graphs. Once again, I'll say it's all important is the input that you put in, the data that you provide the models is what's important, not how sophisticated the model is. Well, you're going to find temperature measurements all over the place. They've got a dozen different measurements for temperature over the same time period. So right off the bat, if they ever say temperature's increasing, you're going to say according to what chart? Okay, I can find temperature charts that show cooling. I mean, the key is they haven't decided, even the IPCC hasn't decided on a temperature chart. Well, here's a temperature chart that measures both temperature and CO2. The black line is the rate of ascent, or the slope, of CO2. And as you can see, the slope of CO2 is very flat, and then it becomes suddenly very sharp in about 1950. That dogleg, okay, happens to occur exactly when they take the SIPL data, which is ice core data, and merge it with the Mauna Loa data. Okay, so they use two totally different data sets, put them together, and lo and behold, you get a sudden shift up in atmospheric CO2. The problem is the temperature gauge. Temperatures were increasing from 1900 to 1940 at this rate, the rate of the red line. Now over here you see CO2 greatly increase the rate of increase. And yet temperature, the red slope, remains the same. So even though CO2's been increasing at an increasing rate, much greater percentage gains, temperature has been unresponsive. It simply has been growing at the identical rate that it was prior to this. More importantly, CO2 has been increasing throughout, and yet you have temperatures falling from 1940 to 1980. So if high levels of CO2 cause temperature to increase, why do we have a cooling period between 1940 and 1980? Now I'm sure they can explain it away, but it's pretty hard to say that if you've got a direct relationship between CO2 and temperature to explain that chart. For one, the rate of increase in temperature doesn't increase, and two, you have a cooling period of a full 40 years during periods of increasing CO2. Explain that one too. And also explain to me why in the world you go from Mauna Loa to get your ice core data. Okay, wouldn't you want to take, if you're going to use they use two different types. They use core samples, which are proxies. Then they use air graph samples from Mauna Loa. First of all, anyone who runs a scientific model knows that you want to control for as many factors as you can. By going to Mauna Loa from Arctic, you're changing as many variables as possible. It's as uncontrolled an environment as you can. My question to Dr. Thompson is, why didn't you take the flash samples or the air graph samples from the SIPL area so that you can at least say that the CO2 at that area has been increasing? Because by comparing, going from the CO2 void Arctic to the CO2 spewing volcano and claiming that CO2 is increasing, it's not too impressive to me. Okay? The other thing is about the way they measure these things. Once again, they use core samples, then they use flash data. Well, let's go take a look and let's just look at a consistent way of measuring temperature. Why not use maybe, let's say, instead of using core samples, coral, Trora rings, let's say, why don't we use a thermometer for God's sake? Let's use let's try a novel idea. We're going to use a thermometer to measure temperature. Well, if we do, and we find the longest thermometer track record, it's from the Albany, New York weather station. And what do you see there in 1822? What was the average temperature? 49.2. In 2005, what is the average temperature? 49.2. So over a 150-year period, the Albany, New York, which is the longest consistent track record of direct measurement through a thermometer in the northern hemisphere, shows no global warming. In fact, if you download the data and run a regression on it, you find out that the slope is negative. It actually shows that there's been cooling since that time period. Now, Dr. Thompson, one, he downplays the sun, and two, he ignores it. I mean, very rarely, if you listen to his presentations, he rarely brings it up. He only brings it up if it's mentioned. Well, lo and behold, they've done a lot of research on this. They don't like to mention it, but here's the correlation between sunspots and temperature. That, to me, is a pretty doggone good type. I'd be willing to bet if you get the correlation results on that, you're going to get an R squared or an adjusted R squared, depending on how many variables they're using. I'd say probably at least 80 or 90. Meaning that 80 or 90% of global warming can be contributed just to the sun. They were pretty smart because what they do, they added on the CO2 chart to show you that this increase in CO2 doesn't correlate well with temperatures at all. However, you can see that the sunspots clearly match up extremely well. Lo and behold, what's there up there that says the Telegraph, the COUK? The sun is warmer now than in the past 11,400 years. Okay. Now, it's not a leap of logic to think that if the sun's the hottest that it's been in 11,400 years, that the Earth might be a little bit warmer. Okay? That is the radiator of the Earth, by the way. Okay? Here, once again, sunspots and temperatures. This is the interesting thing over here. They have a prediction for the climate. So this is sunspot numbers and date. And as you can see, we're going to be reaching a low in 2010. So we're going to test this theory out. My bet is that we're not going to be setting records in temperature over the next 3 or 4 years. We're going to start to see the temperatures going down. And guess what? This winter alone was what, the coolest winter in what, 30-some years? Right? This winter here in Columbus has been setting records. Look at the temperature gauges over the country. Record lows have been being set this summer. And once again, the internet skeptic's going out on a limb and he's making a forecast. You're going to start to see cooling periods going into 2010, not warming. And I guarantee you CO2 is not going to be dropping rapidly. Okay, once again, here's their constantly increasing CO2. This comes from Mauna Loa. And once again, just ask yourself, what's the logic behind going and grabbing air grab samples, flash measurements, off of a CO2 spewing volcano, surrounded by a CO2 spewing ocean and tropical rainforest and jets and traffic. You got it. The also thing is both Al Gore and Lonnie Thompson show graphs like this. CO2 is invisible. CO2, by the way, is what you exhale. CO2 is plant food. CO2 is airborne fertilizer. Matter of fact, because we've had an increase in CO2, the crop yields have gone up and we've been able to feed all these more people. Think about what happens if we yank all the CO2 out. You got it. People starve. Okay. Here's the other one. Just use some common sense. They claim that CO2 on that one chart is 20 to 30% higher than any time before in history. Why then isn't the temperature anywhere near an all-time high? And we're going to get to the charts to discuss that, but I want you to think about that logic. If in fact CO2 is at a record high, shouldn't temperature be at an all-time high? Oh, shoot. System is performing routine maintenance. Oh, rats. Well, Dr. Thompson, I'm going to have to continue this at another time. Our computer system here just went down. You're lucky, okay? I'll be back, though. Unfortunately, our system goes down for computer maintenance, and we'll have to address this later.
This is bullshit.
Come back later.
All right, well, we'll have to